Hi everyone, my name is Saiful and we'd like to go through this assembly code where this code helps us in counting negative numbers. So we have a set of numbers here in array. We declare in array these 4 numbers and this 0 is just an indication that we are at the end of the array, and this code will help us in counting those negative numbers. Let's go through a bit. So we load R0 to the address of the arrays to direct us to these arrays that we set earlier, and we reset or set R1 as 0, where if we encounter negative numbers, it will plus 1. It will add to this value, but initially we will have to set to 0 first, and then we will load R2 register 2 to the address of the result, which is here. So how it does the negative numbers is basically we will have to loop all through the 4 numbers. We will load the first numbers into R3, which is from R0 here, and then BEQ means branch if not equals to 0. Branch if equals to 0, I'm sorry. So if the numbers that we load from R0 here, from the numbers here, equals to 0, which is this one, it will jump to done, which means we store whatever count that we have into R2, which is the result. Okay, then if not, we will add to the address by 4, which means it will point to the next number, which is this number. Okay, how we check is we compare whatever we loaded earlier to 0. If the number is greater than 0, which means a positive number, we will go back to here and we will load the next number. If not, we will add R1 by 1, which means we found one negative number and then we load to here. Let's see what we can see from debugger. Okay, so before we start, we would like to check the memory windows. Let's put here memory windows first. Okay, and we will also like to watch the watch windows here, so we can see the counting or the value of numbers here at the end of the debugging mode. What will be these the value of negative numbers? So let's step one by one. So we load R0 from main. Okay, so this green area indicates that the line has been executed, and this pointer here indicates the next line to be executed. As you step in by pressing F11 or this button here, it will execute this line. Let's see, Control F11. Okay, so we have executed this line, load R0 numbers. So now you can see from your left area here, R0 is equals to this address. We can type this address here. Okay, it's already written here, and we can see whether these numbers are in the address or not. As you can see here, AA, BB, CC, DD, which is these numbers, and then 7F 853982, which is this one, these numbers, and then these numbers 80, 82, 63, and 64, which is these numbers, and then 0. Okay, so let's step further. We have confirmed that these numbers contains this address. Okay, then we go. Okay, now we reset R1 equals to 0, which is the counter negative number, and we load address of the result into R2, which is this address here. Okay, then we start or grabbing those values from numbers into R3. Okay, now we have executed this line. You can see R3 equals to these values over here, which is the first value we have in the numbers array. Okay, then we compare whether the numbers is 0 or not. Then we go to the next address. So let's see whether this number is negative or not. So we will compare these two R3 to 0 and see at the status registers, this n indicates its negative numbers. So we will use this to help us in knowing whether the numbers are negative numbers or not. So these first numbers here that we have loaded from R3 is negative numbers because we can see from the status registers that n is flagged to 1. So when n is flagged to 1 is not greater than 0, so it will not go to loop yet. It will go straight to add R1, which is our negative number counter, to 1, which is now R1 will be 1. See, 1 negative number. Okay, then we can loop back to R3. We loop the next number. Okay, so the next number is this number. You can see from the core here, R3 is 7, 5, which is these numbers. And then we go through the step again. So is it greater, is it equals to 0? It's not, so we go add to the addresses of R0, which points to the next value. And then we compare to R0. Let's see. As you can see, these numbers here, when we compare, when we execute the compare function, it does not flag n equals to 1, which means this number is positive number. So because it's positive number, it is greater than 0, it will loop back to here. See? Okay, then we grab the next number, which is this number, and then we check again whether the number is 0. It's not, then we point to the next number, and we compare again. Okay, now once we compare to 0, then the n status registers flag to 1, which indicates that the numbers, the values are in fact negative numbers. So we add to the R1 counter to counter another 1. Now it becomes 2 negative numbers. From this address, we have found 2 negative numbers. So we loop back again to the 0. See, R3 equals to 0. And we check. Okay, done. Okay, done. So once it's done, it will store whatever count that we have just now, which is 2, to R2, which is the result. Then we can see result here. It will display 2 negative numbers, 2 counts, or value 2s. See, value equals to 2, which indicates that the program detects 2 negative numbers.